Titan II, the largest and most powerful ballistic missile in our arsenal. Hopefully, we'll never have to use it. However, we must be ready to launch it on a moment's notice. Maintaining this missile in a constant state of readiness is a tremendous responsibility, which requires the skill, knowledge, and dedication of many individuals working together as a team.
This is the story of a part of that team, the people who handle the propellants. They are a small but elite cadre of technicians with a job that requires an intimate knowledge of the propellant transfer system.
Be working in no loan zone.
A typical day begins at the main base. Today, a staging area. The assigned duties to be performed at a remote missile site somewhere in the desert. Today, they will transfer propellants.
We're going to have Airman Elsie and Airman Brown will be Silo 1. Airman Moss, Airman McMillan will be Silo 2. Airman Moore will be Rifko in the blast lock. Airman Preciado, Airman Ashby will be topside on the holding trailer Team 1. Airman Gardner, Airman Birchmeyer will be topside on the holding trailer Team 2. And Airman Zosh will be Rifko topside. Are there any questions? Okay, let's get in our trucks and go.
The team must travel in convoy to the missile site. At the missile launch complex, the special trailers and lines required for propellant transfer operations are in place. It has taken the PTS team several days to move this equipment from the main base and set it up correctly here. When the convoy arrives at the site, the PTS team must penetrate site security. To do this, the team chief or assistant team chief calls the MCCC, the Missile Combat Crew Commander, who is on duty in the Underground Launch Control Center. If he receives proper identification, the MCCC releases the gate lock and the convoy enters. To maintain site security after the convoy has entered, the chief or assistant must verify that the gate is closed. At the access portal, the team chief receives permission by phone from the MCCC to enter into the entrapment area. To obtain access to the underground areas, the team chief codes in with the MCCC, using the code sheet he obtained from the codes control section on base.
Delta Hotel. Okay, I'll call you right back.
With his code verified, the team chief burns the code sheet before allowing the rest of the team to enter.
Okay, could I get the auto, please?
As the team enters, they descend into a rare and challenging world, the world of Titan II.
The main components of the underground launch complex are the access portal, blast lock area, control center, and missile silo. The access portal is the only entrance into the underground launch complex. The PTS team must pass through the blast lock area, which contains 3 separately controlled blast doors, then through a short cableway and into the launch control facility, where the team chief must report to the MCCC. Inside the Launch Control Center, the MCCC gives a silo entry briefing to the PTS team, site maintenance officer, and quality control representative.
Good morning, sir. We're here to unload Stage 1 oxidizer.
Okay, let me give you the maintenance briefing. Function 33 will be accomplished after all actions.
The site maintenance officer, or SMO, is responsible for all maintenance performed at the site, while the quality control representative, or QC, ensures that everyone follows the appropriate technical data throughout the entire transfer operation. After the maintenance briefing, the team leaves the control center to prepare for the oxidizer transfer. The initial procedure, known as PREPS, ensures that the entire PTS system, from the topside area to level 8 in the missile silo, is ready for the propellant transfer. The entire PREPS procedure takes approximately 4 hours, and at some bases is done by a special PREPS team prior to the arrival of the PTS transfer team. During this procedure, the team follows TOs requiring them to perform such tasks as checking the electrical systems for the Stage 1 oxidizer, installing polyethylene sheeting to protect engine components beneath the fill-drain quick disconnect, and connecting the vent to the missile.
When the crew completes the preps, the PTS team chief, site maintenance officer, and the safety representative perform a safety walkthrough. Their check includes the VDAP, or vapor detector panel, in the blast lock area. Beyond this, they enter the cableway which leads to the silo. Using a checklist throughout, the crew checks each item, inspecting the entire missile complex to verify that it is ready for the propellant transfer. Among other things, they call for klaxon checks. They inspect the decontamination shower next to the blast lock, first aid equipment, sensing devices. They then pass through the long cableway escape route and into the silo. Within the silo, there are many safety checks which this team must perform.
During the safety walkthrough, other PTS team members are busy preparing for the propellant transfer. Those who must wear the rocket fuel handler's clothing outfit, or REFCO, perform a pre-dawn inspection of the suit. This involves checking the ventilation system for defects and the gloves, boots, and torso for small leaks or tears. The personal clothing and equipment technician fills the environmental control units, or ECUs, with a mixture of liquid oxygen and nitrogen, using a portable liquid air storage tank known as a DWAR. When completely full, the ECU will provide approximately 60 minutes of air for breathing and ventilation.
After the safety walkthrough, the SMO and the MCCC gather information from the wind and temperature recorders in the Launch Control Center. Both men relay this information to the base weather station, which uses it to compute the coordinates for a toxic corridor. The MCCC and SMO then use these coordinates to plot the corridors on area maps. If an accident were to occur, they would have to evacuate everyone from this corridor. Based upon the corridor they have plotted on this map, these officers can determine that weather conditions are favorable for propellant transfer. They will now notify proper base authorities and request permission to flow propellants.
Hey, we got permission to flow. Guys, ready to go? Let's go. Okay, good job.
During the propellant transfer, the PTS team chief, who's responsible for the entire operation, is located topside in the control trailer. Through a radio-type maintenance net, or RTMN, he directs his personnel through the various phases of the operation, constantly maintaining communications discipline.
The SMO usually remains with the team chief in the control trailer. He is responsible for monitoring the propellant transfer and informing job control of any problems which may arise.
While the team chief and SMO are performing their duties inside the control trailer, two PTS technicians in REFCO suits monitor the oxidizer holding trailer. These technicians have two backups who are located in the protective clothing and equipment van.
During the transfer operation, the MCCC remains in the Launch Control Center. He monitors the PTS operation and informs the SMO and team chief of any significant changes in the status of the missile complex.
In the blast lock area, two of the four PTS technicians have donned their REFCOs and are proceeding to silo level 7, where they'll be making connections for the propellant transfer. The two remaining PTS personnel are backups for those working in the silo. They stay in the blast lock area with the PC&E specialist during the operation.
Ground, pressure drain disconnect, and surrounding area for foreign matter.
Roger, TC. Ground disconnect area is free from foreign matter.
Copy. I want you to rotate the ground disconnect locking sleeve counterclockwise slowly until threads disengage.
Roger, TC. Stand by.
Personnel working in the silo must wear the REVCO to protect them from the toxic effects of the liquid or vapors which may be released during a propellant operation.
Be advised, there's a possibility of a klaxon.
Close teamwork is vital for everyone concerned because there are hazards involved in transferring missile propellants.
Copy. Remove the airborne disconnect pressure cap.
Roger, stand by and remove pressure cap.
As professionals, members of the PTS team recognize the need to closely follow all safety precautions and technical orders.
Roger, TC, pressure cap's been removed.
Install the thread protector on the pressure cap threads of the airborne disconnect.
Roger, TC, stand by. Roger, TC, the thread protector has been installed.
Copy. Align the ground disconnect index grooves with the airborne disconnect keys. Slip the ground disconnect over the airborne disconnect and rotate it clockwise until it stops.
Roger, TC, stand by.
With the fill drain hose now connected, the PTS technicians retract and lock the telescoping sections on the work platform. Then, a technician in the blast lock area places the switch to the open position. This allows the propellant to flow from the missile to the pump room. When the propellant reaches the pump room, it causes the system not drained indicator to light up in both the pump room and control trailer. A PTS technician in the pump room verifies this light to the team chief. Next, the team chief presses the push button activating the pump, which transfers the propellant from the pump room to the oxidizer holding trailer. Topside, two PTS technicians monitor the liquid level indicator and inform the team chief when the oxidizer has reached the holding trailer. Then they open and close the appropriate valves. Next, they perform visual leak checks of the system. Personnel in the silo area also monitor the system for leaks.
Piping and the stage 1 missile.
Roger, TC, leak free and normal.
Copy. Leak free and normal.
When the missile tank is empty and the liquid in-line indicators are out, the technicians close the valves on the holding trailer and the switch in the blast lock area. To eliminate residual oxidizer in the stage 1 fixed piping, the technicians remove the fill drain hose from the missile and connect it to the pressure drain. Then, to remove the residual oxidizer from the missile, they connect the dead leg drain hose to the facility. Then to the missile dead leg drain connections. The propellant is now out of the missile and in the holding trailer topside. Standard procedure includes purging of tanks and lines. Missile maintenance technicians can now replace the missile tank seals, perform leak checks, and accomplish other maintenance as required. Then PTS personnel condition the propellant in preparation for loading.
Then, the SMO, QC, and MCCC calculate how much oxidizer will be required to load back into the missile. This is known as determining the rough and final load. In making these calculations, the SMO obtains the engine mixture ratio from the load sheets and the oxidizer temperature from the holding trailer. He obtains the fixed line volume from the tags and, using the TO, along with values obtained, calculates the rough load. After going through several additional procedures, the SMO computes the fine load figure. Then, both the SMO and QC consult with the MCCC, who has gone through the same procedure. Following a brief consultation, they agree on a final load figure.
When the holding trailer contains the fine load figure, PTS personnel prepare to load the missile. On-loading procedures are basically the same as those for off-loading. First, a safety walkthrough. Then, obtaining permission to flow.
Permission to flow. The maintenance officer is coming topside at this time.
And positioning PTS team members in the blast lock area, holding trailer, and silo area. PTS technicians connect the fill drain hose to the missile, open the proper valves in both the holding trailer and silo, and let the oxidizer flow by gravity into the missile.
Copy, holding trailer. I want you to monitor LLI 201 and let me know when we have flow.
Roger, TC, we have flow at this time.
When members of the PTS team observe prescribed safety procedures and follow the technical orders throughout each phase of their jobs, they will successfully complete each propellant transfer operation. The long history of propellant operations reflects this as the only way you can handle Titan II propellants safely.
But never forget, the Titan II propellant system is only as safe as you are.